think that the ECHORD and ECHORD++ project are very well known because they have been around for 10 years. They are finishing, so you will not hear any longer about ECHORD beginning next month, but essentially I think the heritage that has been left by this project has been very, very significant. So what is ECHORD? Actually, you see data there, and ECHORD++, this one. And essentially is based or is trying to take advantage of the best practice that were learned during the ECHORD project, and essentially to deal in a systematic manner with the very difficult task, especially in Europe, of bridging the gap between the prototype and the product. So overcoming what is known as the valley of death, especially addressing the needs of SMEs. And doing this, as I said, in a systematic manner and using different tools. So those are the numbers that summarize the activity and, in a sense, also the impact or the involvement that the ECHORD 2 ECHORD project had in these 10 years. So a huge number of companies involved, of institutions involved, of evaluators. Essentially, we learned a lot about how to identify good ideas, how to encourage these good ideas to be developed to TRL, which were substantially larger than at the beginning, and to get close to the market, to accompany these initiatives. It was a very important lesson. By the way, in these days, I personally saw so many different initiatives based on this concept. So ECHORD was a pioneer initiative, but today this methodology is adopted systematically in robotics, and of course is also improved, which is obviously what we want to do. Which were the main instruments, new instruments that we used during ECHORD++? Essentially, the idea of the experiments. Okay? The second is the concept of robotics innovation facilities, and the third is the idea of the public and user-driven technological innovation, or PDTI. Each of them had a tremendous value. Here you see the instrument of the experiment. So what is an experiment as we define? Is a small to medium-sized scientific research or technological development project with a duration of 18 months involving a team of one or more research institutions, the robotic manufacturers, or putting together the industry needs and expectation with the scientific and technological abilities to solve what is needed to address and to go toward the market. A funding for each experiment of 300,000 euro. And we had 2 calls with a total of 31 experiments that were funded. So here you see the impact of experiment. So 27 experiments, 27% from the first call were commercially exploited, 58% developed a new product, 16% a new service, 42% plan to bring the solution directly to the market, 20% have already secured funding, and spin-off companies were created. Again, think about 10 years ago when we started and how this was evolved through the years. Today, actually, we learned the method, and so similar brother or sister initiatives essentially can have high efficiency. That is, I give a definition, the ratio between contacts and contracts, okay? Essentially, in engineering terms, is the efficiency, so how many good ideas you are able to bring to the market. So those are figures, and we expect that in the future, these figures will further improve. We also had what is called the Experiment Boost program. That is a new instrument that was established with the goal of supporting entities previously involved in the ECHORD experiment. So essentially to further tutor and support with market analysis, business plan, entrepreneurship coaching, IP support, and other initiatives, certification, selected experiments. So the idea of a further booster of that. And you can see here a summary of the call 1 and call 2. And essentially, the idea is the results, in fact. According to the evaluator, there are many good evaluators here. Andreas is one of those, for example. There are many of you who were involved. So high-level, high-quality scientists or industry people who evaluated the level of TRL that in average increased of 2 levels. The RIF, or Robotic Innovation Facilities, were also a major action. And you see there how many collaboration, interaction, clients, and activities were performed. And this is a substantial heritage that will remain. In fact, for example, the Digital Innovation Hubs, DIH, is a natural continuation of the activity of the center that, the RIF that were established at a European, also national level. For example, our RIF is a deeply involved as a leader in a national initiative on technology transfer. So we learned many lessons, how to conduct a personal meeting, to manage processes, to create a collaborative platform, to pursue global consistency with local activity. For example, one thing we learned is that the collaboration with companies like a Goshen in terms of space. This is something that the RIF in Bristol pointed out. Customers essentially like to contact technology transfer or a research center within a scale of 50 kilometers, okay? It's a very, very local. So we want to act globally. That is a European methodology, but a local impact. So we learned this very much through, as I said, these RIFs that were located in Bristol, in Paris, and in Pisa. There's a clear difference in terms of size, and we learned how really to deal with different scale of activity and of customers. And then we implemented this concept of PDTI, that Public and User-Driven Technological Innovation. That is a way to learn and to listen really about the needs of the public sector and to translate it into usable and affordable solutions. The main actor in this has been the administration, the city of Barcelona, and the main activity, one of them will be demonstrated next week at a final review meeting, is about sewer. So sewer, there are robots, flying robot drones, and ground robots essentially are used to monitor the sewer in Barcelona, or about the geriatric assessment, again starting from the needs of the public administration and demonstrating, proving with them there is a payback period, there is a market potential, but there is something that is acceptable and affordable with real people. So essentially, in summary, what we believe is that through the combined strength of all its unique instruments, ECHORD++ has been initially, and of course, paved the way to further actions in application-oriented EU-funded robotic research project. So overall, we believe a success story. And now I'd like to involve my colleague, Professor Gianluca Palli from the University of Bologna, who is describing one of the successful experiments, the one called WIRES. Luca.
Thank you. So, thank you. I'm Gianluca Palli from the University of Bologna. I'm the coordinator of the WIRES experiment. And in this experiment, also the Seconda Università of Naples and IEMA, that is a company active in the manufacturing of switch gears and control gears for, in particular, automatic machines were involved. And yeah, the project started because of the previous experience from my university and the Second University of Naples about tactile-based manipulation, our experience coming from a previous European project. And we get in contact with this company, IEMA, and they have this specific problem that they want to automatize the switchgear cabling. Switchgear cabling is an activity that is completely performed by human operators because of the variety of designs that change from product to product, the very difficult manipulation tasks involved in this process. You have to manipulate electric cables. You have a lot of cables in a very limited space, a number of components, several times equal the one to the other, and there may be hundreds and hundreds and thousands of cables in the same switchgear. So the company also asked a specialized company in this sector to provide some solution, but nobody want to work in this field because it's, of course, a very difficult task to automatize. So after the investigation on the problem, we found that there are different issues related to the actual process. The first is that there's no exploitation of the information coming from the design of the product to plan the activity, the manual activity, since the documentation is only based on paper that are read by the user, by the manufacturers, the human operators during the activity. And also there's another problem, let's say, related to the fact that most of the activities that are performed during this manufacturing are very repeatable activities. So there's a very limited added value in the activity of the people there. So what we developed inside this project is a combination of software and hardware solution to deal at least with the activities that are most repetitive in this process. So to exploit robots to pre-process the product, the switchgear, before letting this to the, let's say, reworking by the human operators to complete the production. One of the also peculiarity of this of the company that is involved in this process is that they usually work with unique items. They have no production, serious production lines. So the aim is mainly to reduce the costs in the sense of the amount of time of man hours used to produce these items in such a way that the human operators can be reused to extend the production. For sure, we need thank you. We need to develop different tools. So the first issue in the pipeline of the process is to develop a software package able to translate without human intervention what is the design of the product into what the robot needs to know about the activity. So to perform the direct transfer from the design to the robot activities. And a lot of time was spent in this this part. In particular, it's because we found that there's some information missing, because the entire, also the market in that field is not ready and is not shaped to perform that kind of automation. So we had also to add some information, in particular about the components that are used, that you can see there in the bottom picture, the bottom left picture. There's no real information about the functionalities of each component, so where you have to connect the wires, where there are the screws, in which direction they are. So this information is not available from the manufacturer. So we have also to add this information. Then we developed tools to detect the object, both from the vision point of view and from the manipulation point of view, because first of all, for sure, we need to see where the cables that we have to manipulate are, to track them along the path, eventually even if in a crowd environment where there are multiple cables. We need to also detect very precisely which is the position and orientation of the tip, because the task is to insert the tip of the cable into a connector in the components. Then mostly of the activity was in developing vision systems, exploiting a lot of deep learning to detect and track cables, to perform the activities of locating the wires, manipulating the wires, and so on. Then we also introduced the tactile sensors that we developed in previous project, because one issue is that since there are a really large number of cables in a very reduced space, we can't rely on image only to deal with the very last part of the activity during the insertion task. So we need to feel what is happening during this task by means of tactile sensors. At the end, we came out with this prototype of a specific tool to perform these activities. Is this, let's say, smart gripper with a 4-star sensor in the wrist interface, a computer controller screwdriver, a camera, tactile sensors in the fingertips, and embedded controllers for the 4-axis gripper. Then this was applied to a reduced scale demonstrator that you can see here in this picture on the bottom right, and we demonstrated this in a real production scenario, and also we bring this demonstrator to the automatic affair thanks to the ECHORD Plus into the ECHORD++ booth. So at the end, what we gain from this experience is that we were able to develop an interesting task and interesting activity for automation and manufacturing. And mainly now we are still in contact with IEMA, with the company that already founded a research grant to directly put into production what is the main points, in particular the software package to translate the product design into the robot activities, to improve also other activities, not only the wiring, but also the testing of the system. Then also the company and we are planning to create a spin-off to commercialize this product and to bring it into production. And also we recently submit a proposal to go on with the development, because of course wiring is not, the problem is not closed. We need to work again to close the problem.
Thank you so much. So many perspectives for this project as well. Thank you to both of you. Okay.